This video explores the topic IoT and AI for air quality monitoring within the framework of the European project titled Personalized Education in Measurement Science and Technology, Empowered by Machine Learning. In this presentation, we focus on how IoT and AI technologies work together to provide accurate and continuous air quality monitoring. IoT sensors measure key environmental parameters such as particulate matter, temperature, and humidity, and transmit these readings through a unified data acquisition and communication framework. We also highlight the role of AI and machine learning, which transform raw sensor data into meaningful insights. Through data preparation, model training, and real-time prediction, AI models can detect patterns, estimate pollution levels, and generate alerts far more effectively than traditional methods. The workflow integrates cloud platforms, microcontrollers, and intelligent algorithms to support reliable, scalable, and automated monitoring. Examples from smart cities, environmental IoT networks, and public health applications demonstrate how AI-enhanced IoT systems improve accuracy, responsiveness, and decision-making. Air pollution remains one of the most significant environmental risks to human health. Among the various pollutants, fine particulate matter, especially PM2.5, is particularly dangerous because these tiny particles can penetrate deep into the lungs and even enter the bloodstream. Long-term exposure increases the likelihood of cardiovascular problems, respiratory illnesses, and other chronic conditions, making air quality a critical public health concern. Real-time air quality monitoring provides an essential early warning system for both communities and policymakers. By continuously measuring pollutants and environmental conditions, we can detect sudden increases in harmful particles, identify pollution hotspots, and evaluate the effectiveness of mitigation strategies. This timely information supports faster decision-making, whether issuing public alerts, adjusting traffic flow, or implementing temporary restrictions to protect vulnerable populations. Ultimately, continuous monitoring helps create healthier, more resilient urban environments. The Internet of Things, or IoT, refers to a vast network of interconnected devices that are equipped with sensors, embedded software, and communication capabilities. These devices continuously collect data from the physical world, such as environmental conditions, motion, temperature, or air quality, and exchange this information with other devices in cloud platforms. In a typical IoT system, sensors capture raw data, gateways securely transmit it, and cloud services process and analyze the information in real time. Users then interact with this processed data through dashboards, mobile applications, or automated control systems. This seamless flow, from sensing to analysis to user interaction, enables smarter decision-making, automation, and improved efficiency across domains such as smart homes, healthcare, industrial automation, and environmental monitoring. By integrating sensing, communication, and analytics, IoT transforms ordinary objects into intelligent, responsive components of a connected ecosystem. This IoT-based air quality monitoring system operates through a series of interconnected components that work together to deliver real-time environmental insights. The process begins with sensors that measure PM2.5, PM10, temperature, and humidity. These sensors capture raw environmental data, which is then sent to a microcontroller, such as an Arduino or an 32 Spanish pesetas. The microcontroller processes the readings, performs basic filtering, and prepares the data for transmission. Connectivity technologies like Wi-Fi or LoRaWAN enable the device to send this information securely to the cloud. Once the data reaches ThingSpeak, it is stored, visualized, and analyzed. ThingSpeak also serves as a platform for integrating AI and machine learning models, which use historical data to detect patterns, forecast pollution levels, and trigger early warnings when necessary. Finally, the results are presented to users through dashboards and alert systems. These visualizations make it easy to interpret trends, understand environmental changes, and take timely action. Altogether, this workflow demonstrates how IoT, cloud platforms, and AI can be combined to create a powerful system for continuous air quality monitoring and prediction. Sensors continuously measure particulate matter, temperature, and humidity, sending updated readings to the microcontroller every few seconds. All collected data is uploaded to ThingSpeak, where it is automatically aggregated, visualized, and analyzed in the cloud. Devices can connect through REST or MQTT, and MATLAB scripts can run in the background to compute statistics, enrich the data, or trigger real-time alerts. Because ThingSpeak handles storage, charting, and scheduling, prototyping becomes much faster. You can focus on the measurement system itself without building servers or custom web applications. The modeling workflow begins with careful data preparation. Sensor readings for particulate matter, temperature, and humidity are first cleaned to remove noise, missing values, or outliers. Because each sensor may log data at different intervals, the streams are synchronized and then normalized to ensure consistent scaling before training. Once the data is ready, several machine learning models are trained to learn the relationships between environmental variables and particulate concentrations. These include standard regression methods, such as linear regression and neural networks, as well as more advanced ensemble techniques like random forest, which can capture nonlinear dependencies in the data. For prediction and evaluation, the trained models generate real-time PM forecasts that are compared with measured ground truth values. Performance is assessed using metrics such as mean absolute error, and in recent experiments, random forest models with 100 trees consistently achieved the lowest error, making them the most reliable choice for air quality prediction in this setup. Deploying an IoT-based air quality monitoring system comes with several practical challenges. First, sensor calibration and drift are critical issues. Low-cost sensors tend to lose accuracy over time, so regular recalibration is necessary to maintain reliable particulate measurements. Equally important are connectivity and power constraints. Devices depend on stable Wi-Fi or LoRaWAN links, and battery-powered units must be optimized for long-term energy efficiency. Another challenge is data quality. Environmental noise, missing values, and inconsistent sampling intervals can distort the dataset, requiring careful pre-processing before analysis or model training. Security and privacy also play a major role, since all data is transmitted to the cloud. Protecting these streams with secure communication protocols and encryption helps prevent unauthorized access. Finally, machine learning models often struggle to generalize across different locations or seasons. Continuous retraining with new data ensures the model adapts to changing conditions and maintains high predictive performance. In summary, IoT-based air quality monitoring provides a powerful and accessible way to observe environmental conditions continuously and at low cost. By leveraging platforms like ThingSpeak, data collection and visualization become straightforward, allowing researchers and communities to focus on interpretation rather than infrastructure. AI and machine learning models further enhance the system by delivering real-time forecasts and actionable insights that can guide public health decisions and support early interventions. Looking ahead, the system can be expanded by incorporating additional pollutants such as nitrogen dioxide and carbon dioxide, which would offer a more complete picture of urban air quality. Integrating edge intelligence will enable faster, on-device processing and more responsive alerts. Finally, engaging citizens through mobile apps and interactive dashboards will help raise awareness and empower individuals to take action based on reliable environmental data. Thank you for your attention. This video was produced through the collaboration of SS Cyril and Methodius University of Skopje, the University of Niš and Politecnico di Milano, within the framework of the European project Personalized Education in Measurement Science and Technology Empowered by Machine Learning. More information about the project can be found on the project website and LinkedIn page.